Okay, so today we're going to be talking about rational inequalities. So we've gone over polynomial inequalities, okay, finding solutions where a function is above the x-axis or below the x-axis, or where it's the y values are positive or the y values are negative. We did them with polynomials. Now we're going to do them with rational functions. Okay, so very similar. Okay, the only difference is that in rational inequalities, we just put zeros on our number line. Now we're putting the zeros and our asymptotes on the number line. Okay, so just like we did with graphing rational functions, we need to find our x-intercepts and our vertical asymptotes. Okay, so our x-intercepts are going to be from the numerator. So I have two x-intercepts. One at, I'll put them in coordinate form so that it doesn't get confusing. So I have one at positive 4 and one at negative 2. My vertical asymptotes for this function are at 0 and at negative 5. So I'm going to put all 4 of those values onto my number line. Okay? So first, I'm going to put 0, my asymptotes, and instead of putting a 0 on top to let me know it's a 0, since it is a asymptote, I'm going to put a u there, which stands for undefined. So that's telling me that that is an asymptote. Same thing for negative 5. Put a u there, because those are where my two asymptotes are. Then I put my zeros in. So at negative 2 I have a 0, and at positive 4 I have a 0. And so that's the reason why in the polynomial inequalities I had put zeros above them, is so that you get acclimated to doing that, so that when we got to the rationals, you'd know which ones are zeros and which ones are asymptotes, which is going to make a big difference later. Okay? So now that I have my asymptotes and my zeros, now we have to test all of my information. Okay, so we're going to pick values on either side of these to find out if it's positive or it's negative, because we're looking for the solutions where my function is less than 0, which those are negative numbers. Okay, so we're looking for the negatives. So first, I'm going to plug in negative 6, because it's on the left side of negative 5. And again, I'm going to plug negative 6 into each of my factors, find out if it's a positive or a negative, and then find out what it nets, if it's totally negative or totally positive. Just like we did with graphing. So when I plug in negative 6 into this one, I get negative on top, negative. On the bottom, I get positive and negative. Like that. And a negative divided by negative is positive, but I get a negative divided by positive, so this right here is negative. Okay. Then I'm going to go here and pick a number between negative 3 and negative 5. Okay. And again, I'm going to plug it into each value. When I plug it into the top, I get negative, negative. On the bottom, I get positive, positive. And a negative times a negative is positive, so these end up all being positive. So here it's positive. Then I'm going to pick a number between negative 2 and 0, like negative 1. When I pick negative 1, I get negative, positive, positive, positive. So this is negative. Then I'm going to pick positive 1 because it's between 0 and 4. And I get negative, positive, negative, positive, which means this part is positive. And then lastly, I'm going to pick 5, and I get positive, positive on top, negative, positive on bottom, which means I'm total negative there. Okay. Now, I need to find the solutions to this. Okay. So I'm looking for where this is less than 0, which are negative numbers. So anywhere I see a negative, I'm going to put an X there. So X there, X there, X there. Then I'm going to bring down all of my zeros or my asymptotes. So I bring -5 down, -2, 0, 4. And anywhere between an X and a number, I'm going to put the less than symbol. And these are my solutions. My solutions are when X is less than -5 in union with -2 to 0, and when X is greater than 4. So those are my solutions. All right, so let's look at the second example. Okay, so the second example is very similar to the first. Set it up exactly the same way. So first, let's find our zeros, our x-intercepts. So our x-intercepts, we only have 1 at x equals 0. Okay, that comes from the numerator. Then my asymptotes are at x equals -3, x equals 5, and x equals -8. Okay, so let's put all of these on our number line. So -8 asymptote, -3 asymptote, 0 is a 0, and 5, which is an asymptote. Okay. Now we're looking for where the function is greater than or equal to 0. We're looking for the positives. Okay, so again, we've got to do our tests. So we're going to test all these areas. So, got to do something smaller than -8, so like -9. Okay. Now this one's unique because the numerator will always be a negative number. It doesn't matter what I pick for my value. When I plug in for x, this square is going to turn it positive, and then any positive times a negative is always going to be negative. So the numerator is always going to be negative. Okay, so numerator is negative. So the only thing that's going to change the sign is going to be these 3 factors in the denominator. So when I plug in -9, I get negative, negative, negative. So negative divided by negative is positive, positive. So here my function is positive. Okay. Here I'm going to plug in, say, -7. Again, numerator is always going to be negative. This one's going to be negative, negative, positive. Then I net negative here. Then pick a number between -3 and 0, like -1. Again, top will always be negative. The bottom, positive, negative, positive. So this net's positive. Then 1. So that's positive there. And then pick 6. So negative, positive, positive, positive. So this is negative there. Okay. So once we have our sign chart, figuring out where the function is positive and negative, we're looking for where it's greater than or equal to 0. Greater than 0, that means we're looking for the positive numbers. So I'm going to put an X wherever I see these big positive numbers. Okay. Then I bring down my asymptotes and my zeros. And again, since this is set up as number line, in between any number and an X, I can put a less than symbol. Now, I have to also include my zeros. So since my original solutions are where it's greater than or equal to 0, I got to make sure anywhere there's a 0, it's equal to as well. So right here at this 0, I got to make x equal to 0 as well. So these are my solutions. So my solutions are when x is less than -8, as well as, and this is where we can actually condense this part right here. So from -3, this is saying x is greater than -3, right? All the way to less than 5. This whole thing includes every value in between -3 and +5. Because this right here, from -3 to 0, and then this one's from 0 to 5. So since we're including everything, we can condense this into 1 and just say when x is greater than 3 but less than 5. And bring that all down into one thing. And you can see from the sign chart, everything is it's all positive there. Now, these might look familiar. Both of these problems were the notes when we were graphing rational functions, the second one. We already know these graphs and what they look like. And a matter of fact, from this sign chart, I also can tell what my graph looks like. Now think of this number line as my x-axis. If this is the x, right here, this is my y-axis at 0. And if we look at it from that perspective, this is a 0 here. This is an asymptote. This is an asymptote. And this is an asymptote. Right? If we had been graphing this, basically we would have had to do this sign chart. We've done it before. We had to figure out, since this is bigger on bottom, our horizontal asymptote is right here on this x-axis. And we had to plug in values and see if it was above the x-axis or below the x-axis. So like here on this left side, since this is on the positive side, it looks like that. In between -8 and 3, it looks like this, because no x-axis, no x-intercept, it's negative. Here, between -3 and 5, it's on the positive side, and then the positive side, that's because right here it bounces. And on this side, it's on the negative side. So these sign charts actually follow our graphs. So either way, I can use the sign chart to actually graph my rational function, as well as if I have the graph, I can use the graph to actually create my solutions or my sign chart. It all links. Okay? So some people find it easier to do the sign chart and then graph on top of it. Some people find it easier to do the graph and then create the solutions. But I really want you to practice the sign chart so that you know what to do.